Alright, these are the worked out solutions to your Chapter 9 closure, starting with 9-120. Write an inequality to represent the graph at the right. Alright, so the first thing you want to do is identify your boundary line. So that's this line right here. It has a y-intercept of -2, and it has a slope that's rising 2, running 4. So vertical change of 2, horizontal change of 4. My slope is 1/2 x minus 2. This is my boundary line. Now I need to figure out what inequality to put in there. So what I used was a test point. So I knew that 0, 0 was in the solutions. So I substituted 0, 0 into this equation, and I'm looking for what inequality makes this true, which is greater than, and I know it's not equal to because it's dashed. For 9-121, you're going to test this point in both inequalities and see if it works in both of them. Alright, so for this one, it was a solution because it worked in both inequalities. So when I substitute into this one, I get a true inequality, and when I substitute in this one, I also get a true inequality. 4 is greater than -2, and 4 is less than or equal to 4. 1-22, factor these quadratic expressions completely if possible. Alright, so for A, we were looking for two factors of -30x squared that added to x, so 6x and -5x, so we end up with x plus 6 times x minus 5. And for B, you're going to start by pulling out the x, divide out that x first, because it's a common factor, and then you have this trinomial. When you factor that, you end up with x minus 7 and -3x plus 2. Alright, C was not factorable, and for D, you're going to start by dividing out a 2x first, and you're looking for two factors of -36x squared that add to 5x, which is positive 9x, and -4x. So you end up with 2x times x plus 3 times 3x minus 4. Alright, so for A, when I set up my equation, I find that my boundary point is x equals 3. I'm going to test a point on one side of 3, so I'm going to test 0 because it's easy. I end up with -3 is greater than or equal to 9. That's not a true statement, so 0 is not a solution. So it's going to be numbers that are greater than or equal to 3. For this one, when I set up my equation, I got -7/3. Again, I tested 0, and it was not a solution, so my inequality is going to be going less than -7/3. Alright, so for C, we had 2y equals 8. I'm going to multiply by the reciprocal. I get 56/2, which is 28. I tested 0, and it was a solution, so I have an open circle because there's no equal to here, and I'm going to the solutions including 0, so my answer would be y is less than 28. For D, I ended up with 2.5 as my boundary point. Again, it's going to be an open circle. When I tested 0, I got 4 is greater than 24, which is not a true statement, so we're going to be including solutions that are greater than 2.5. Alright, so we have two unknown variables here. How many boys, how many girls came to the dance? So B is going to represent the number of boys, G is going to represent the number of girls. $5 per boy plus $3 per girl for a total of $175. And the number of tickets, boy tickets plus girl tickets, had to be 45, so therefore 45 people. I would recommend using either substitution or elimination for this one. Alright, I went ahead and multiplied the second equation by -3 to create a opposite coefficients here, and when I add these equations together, I get 2b equals 40. Divide both sides by 2, and I get that there were 20 boys. I want to know how many girls there were, so the boys plus the girls has to add up to 45. So if there were 20 boys, that means there were 25 girls. So 25 girls came to the dance. Alright, for 125, you're going to solve each one using the specific method. Alright, so let's look at A first. We're going to use the quadratic formula. A equals 3, B equals 4, C equals -7. When I substitute all of that in, I end up with -4 plus or minus the square root of 100 divided by 6, which is a -4 plus 10 divided by 6 and -4 minus 10 divided by 6. And when you simplify those, you get x equals 1 and x equals -7/3. For the factoring one, we're looking for two factors of -18x squared that add to -3x. So I get x plus 3 times x minus 6. You're going to set each of these equal to 0 and you get your solutions as x equals -3 and x equals 6. All right, for C, you're going to complete the square, and for D, you're going to use a graph. All right, so for C, for completing the square, if I were to create a square with these tiles, I would have x squared here. I would split the 4 and have 2 and 2 on each side. And then I would be looking for 4 units to complete the square. So I need this number here, the C value, to be a 4. So I'm going to add 3 to both sides. Once I have the tiles that I need to make the square, I'm going to write the area as a product. So x plus 2 squared equals 3. And then we're going to solve for x. So I'm going to take the square root of 3. So I know that x plus 2 has to equal the square root of 3. And square roots have both positive and negative solutions. So I'm going to have x plus 2 equals positive square root of 3, and x plus 2 equals negative square root of 3. And then I'm going to isolate the x by subtracting 2 to both sides for each of these, and I get -2 plus the square root of 3 and -2 minus the square root of 3. So my two solutions are -0.27 and -3.73. For D, you're going to use a graph. I used Desmos, so here's my here was my graph on Desmos. Let me just move this over a little bit so you can see. Okay, so I graphed it in here, and then I looked at the intercepts. So we had an intercept at -4 and an intercept at 1.5. So using a graph to come up with those solutions. All right, so for 126, we're going to graph this quadratic function by finding the vertex. It's already in vertex form, and the vertex is going to be 1, -4. Remember that the x-coordinate is actually the opposite, the inverse of whatever number is inside here. So 1, -4 is the vertex. It's either the maximum or minimum. Then we're going to find the x-intercepts by plugging in 0 for y and solving for x. All right, I end up with 4 equals x minus 1 squared. So I know that the square root of 4 must be equal to x minus 1. So there's a +2. So x minus 1 has to equal +2, but it can also equal -2 because -2 times -2 is also 4. So I get x equals 3 and x equals -1. So those are my intercepts, so 3 and -1. So I know that it's going to be opening up, and it's going to look something like this. You're going to skip 127, so the next one will be 128. All right, so if A represents Audrey's age, even if you triple Audrey's age and add 9, it would still be less than 60 years old, since that's Lou's age. So we're going to solve this inequality, figure out the ages of Audrey. All right, so when I solve this, I get that Audrey has to be less than 17 years old. All right, so it's decreasing by 10% per year over the past several years. If it currently costs $5, an exponential equation to describe the situation. All right, so if it's decreasing by 10%, that means the multiplier is going to be 90% of the value, so 0.9 as a decimal. The original current cost is 5, so 5 times 0.9 to the x power. 5 years ago, that would be -5, because I'm going back 5 years, and we get $8.47. 1/3. All right, so for this one, a hair leaps 500 centimeters every 20 seconds. That's its rate. And the tortoise goes 250 every 50 seconds. That's its rate, but it has a 1,000 centimeter head start. Using any method to determine when they catch up. You could use a table, a graph. I'm going to go ahead and use substitution or equal values and set these equations equal to each other. First thing I did was I simplified these fractions, so I got 25x and 5x. So I'm going to solve for x when I set them equal to each other. All right, I get that after 50 seconds, they'll catch up to each other. And when I plug that in to get the distance, I get that they will both be at 1,250 centimeters in the race. All right, and the last one. All right, so for this one, we have an equation of an exponential function, it goes through these 2 points, 3, 13.5, and 5, 30.375. So we have to figure out what's the initial value and what's the multiplier. So I'm going to start with the multiplier. So it's multiplying by something, and it multiplied by something twice. And if you divide 30.375 by 13.5, you get 2.25. So we're looking at what number times itself gives us 2.25, or we're taking the square root of 2.25. And when you take the square root of 2.25, you get that the multiplier is 1.5. Okay, and then we're going to use that to find our zero term. So I'm going to extend this table backwards. And instead of multiplying by 1.5, we're going to divide by 1.5 until we get to the zero term. So when I do 13.5 divided by 1.5, I get 9. 9 divided by 1.5, I get 6. And 6 divided by 1.5, I get 4. So my initial value is 4, so my equation would be 4 times the multiplier 1.5 to the x power.